Hello, my name is Julia Stoyanovich. I'm an assistant professor of computer science and engineering and of data science and director of the Center for Responsible AI at New York University. Today, I will be discussing the challenges of designing, developing, and deploying data-intensive systems responsibly. To start, let us all agree on one thing. AI is great. The convergence of unprecedented data collection capabilities, enormous computational power, and broad acceptance of data collection and analysis as a way to move society forward are offering us tremendous opportunities to do good. We can accelerate scientific discovery in areas ranging from astrophysics to medicine. We can boost innovation in a myriad of ways, from self-driving cars to advertisement targeting and back. We can improve society by improving how governments function, by making resource distribution more equitable, and bringing greater transparency and accountability to government operations. And perhaps most importantly, we can get AI to do all of our work so that we can just kick back and relax at the beach. As a concrete example of the actual or supposed power of AI, let us use data science methodology and consider some cases, and then generalize from these cases. The examples I will use are drawn from the use of AI in hiring, known as automated hiring systems. A well-known report from Upturn describes the hiring process as a series of decisions that form a funnel, a socio-legal technical system operationalized as a sequence of data-driven algorithm-assisted steps in which a series of decisions culminates in job offers to some candidates and rejections to others. The process starts when employers source candidates, for example, by ads or job postings. Next, during the screening stage, employers assess candidates by analyzing their experience, skills, and characteristics. Through interviewing applicants, employers continue their assessment in a more direct fashion. During the selection step, employers make final hiring and compensation determinations. Importantly, data and predictive analytics are used during all of these stages. As put eloquently by Jenny Yang, former commissioner of the Equal Employment Opportunity Commission in the United States, automated hiring systems act as modern gatekeepers to economic opportunity. Why are algorithmic hiring tools so attractive? First, they help employers, large and small, to hire more efficiently, source and screen candidates faster and with less paperwork, and select candidates who likely will do well on the job. These tools are also meant to improve efficiency for job seekers, allowing them to apply with the click of a button, matching them with relevant positions, and facilitating the interview process. We also hear, time and again, that the use of these tools can help us improve workforce diversity. Indeed, an argument being made very frequently is that because humans are biased, we have no choice but to use machines to step in and hire on our behalf. I'm showing you here an excerpt from a famous study by Marianne Bertrand and Sendil Mullainathan, who back in the analog days of 2004 manipulated perceived gender and race on resumes and observed that applicants who were perceived as male and white received substantially more callbacks on the very same resumes. Are algorithmic hiring tools living up to their promise? One of the earliest indications that there's cause for concern came in 2015 with the results of the Ad Fisher study out of Carnegie Mellon University. The authors ran an experiment and found that ads for high-paying jobs were shown far more frequently to men than to women. This brings back memories of the time when it was legal to advertise jobs by gender in newspaper. In late 2018, it was reported that Amazon's AI recruiting tool that was developed with the stated goal of increasing workforce diversity, in fact, did the opposite thing. The system taught itself that male candidates were preferable to female candidates. It penalized resumes that included the word women's, as in women's chess club captain, and downgraded graduates of 2 all-women's colleges. Other examples of discrimination include shutting out people suffering from mental illness, such as depression or bipolar disorder, on the basis of online personality tests, even if they have the right skills for the job. And of showing ads suggestive of a criminal record when Googling for African-American sounding names far more frequently than when Googling for white sounding names, even when controlling for whether the individual in fact has a criminal record. This is problematic because employers often Google for an applicant's name as part of a background check. In addition, or perhaps even before worrying about bias, we should ask whether these tools actually work. Are they picking up useful signal from the data, or are they an elaborate coin flip at best? As Arvind Narayanan, computer science professor at Princeton, depicted here, puts it, are these tools AI snake oil? If a tool helps improve workforce diversity, it admits a sufficient number of candidates of each required demographic or socioeconomic group, but its decisions are otherwise arbitrary. Can such a tool be considered fair? What if these decisions are worse than arbitrary? What if the tool is picking up signal like a person's disability status, and we have no way to know that this is happening? What if it's measuring something about a job applicant that we have no reason to believe to be relevant for the job for which they are applying? How can we know whether a tool works? Well, AI tools are engineering artifacts. We should not take the claim that they work on face. To know whether they work, we should use the scientific method. Formulate a hypothesis that states, in a falsifiable way, that the tool indeed selects employees who do well on the job and is better at predicting that than a random guess would be. What is falsifiability? The philosopher of science Karl Popper explains it eloquently, stating, a theory or idea shouldn't be scientific unless it could, in principle, be proven false. In the complex ecosystem in which automated hiring tools are commissioned, developed, and used, we must ask ourselves who is responsible for ensuring that these tools are built and used appropriately, who is responsible for catching and mitigating discrimination and due process violations, and for controlling the proliferation of snake oil under the fancy label of data science and AI. I think that we all are responsible. But what can we as technologists do? What specifically is our role and our responsibility? In response to this question about responsibility, we've been seeing attempts to regulate the use of data-driven algorithmic tools, such as those that make part of the hiring funnel. This activity is broader in scope than algorithmic hiring, so let's now step back for a more systematic view and discuss automated decision systems, or ADS. The hiring funnel, as well as each component of the funnel, are examples of ADS. These systems process data about people, some of which may be sensitive or proprietary. They help make decisions that are consequential to people's lives and livelihoods. They involve a combination of human and automated decision-making. They are designed with the stated goals of improving efficiency and promoting, or at least not hindering, equitable access to opportunity. And finally, they are either now or in the near future subject to auditing for legal compliance and at least potentially to public disclosure. ADS may or may not use AI, although most of them are built as AI, and they may or may not have autonomy, but they all rely heavily on data. How might we go about regulating ADS, and should we even attempt to do so? While the predominant sentiment in the industry is still that regulation will stifle innovation, industry alone doesn't get to decide. And even in the Silicon Valley, the need for meaningful regulation to ease compliance and limit liability is starting to be more and more broadly recognized. There's much debate on a specific regulatory framework. Should we use precautionary principles that can be summarized as better safe than sorry, or more likely attempt a more agile risk-based method, such as algorithmic impact assessment? All this and more is subject of intense debate, some of which I had a chance to witness firsthand. New York City recently made a very public commitment to opening the black box of the government's use of technology. In May 2018, an automated decision systems task force was convened, the first such in the United States, and charged with providing recommendations to New York City's government agencies about becoming transparent and accountable in their use of ADS. I was a member of that task force. The task force issued its recommendations in November 2019, making a commitment to using ADS where they are beneficial, promoting fairness, equity, accountability, and transparency in their use, and reducing potential harm across their lifespan. The first point reinforces the no to AI snake oil sentiment. While making important points in the report, the task force didn't go very far in terms of concrete recommendations. But we may have an immediate opportunity to make things more concrete. And so I would like to bring to your attention the proposal for a law that would regulate the use of automated employment decision tools in New York City. If passed, this law will apply to the use of these tools both in government and in industry. It will prohibit the sale of such tools if they were not the subject of an audit for bias. The law will also require to disclose to candidates when such tools were used to assess their candidacy for employment, and also to disclose what specific job qualifications or characteristics were used by the tool in the screening. If you'd like to hear more about what I think about the proposed bill, please take a look at a recent New York Times opinion piece that I co-authored with Alexandra Reeve-Gibbons and Hilke Shellman. I'm highlighting some points here that discuss the need for public disclosure, that discuss the need for speaking about individuals who are multiply marginalized, and about ensuring that, in fact, the tools measure what they claim to measure, and that the characteristics that they measure are relevant for the job. Using the proposed law as a motivating example, we now ask, how can the principles of the responsible use of ADS, including in this case bias auditing and public disclosure, be operationalized? And slightly more generally, how should members of the technical community, such as us, approach the responsible design, development, and use of ADS? To answer these questions, let us step back and think carefully about the role that technological interventions, such as data and model debiasing that you surely heard about, can play in supporting the responsible use of ADS. This discussion is necessary to help us find the pragmatic middle ground between two harmful extremes. The first of these is techno-optimism, a belief that technology can single-handedly fix deep-seated societal problems like structural discrimination in hiring. And the second is techno-bashing, and that is a belief that any attempt to operationalize ethics and legal compliance in ADS will amount to fair washing and so should be dismissed outright. In their seminal 1996 paper, Friedman and Nissenbaum identified three types of bias that can arise in computer systems, represented here as a three-headed dragon: pre-existing, technical, and emergent. Pre-existing bias exists independently of an algorithm itself and has its origins in society. Technical bias is introduced by the operation of the technical system, and it may exacerbate pre-existing bias. Finally, emergent bias arises in a context of use and may be present if a system was designed with different users in mind or when societal concepts shift over time. We will fight the dragon with the help of data equity. Equity as a social concept, treating people differently depending on their endowments and needs to provide equality of outcome rather than equality of treatment, lends a unifying vision for ongoing work to operationalize ethical considerations across technology, law, and society. My colleagues and I define the following important facets of equity. Data equity in particular. Representation equity refers to the deviations between the data record and the world that the data is meant to represent, often with respect to historically disadvantaged groups. Access equity is concerned with having access to information, features, data, and models that are needed to evaluate and mitigate inequity. Finally, outcome equity refers to downstream unanticipated consequences outside the direct control of the system. We will now discuss each of these equity types in turn to make the positioning clear. In our discussion, we must note that purely technical solutions will never do. They must be based on a careful consideration of the values that we embed into these systems and into the interventions that we enact. So let's start with representation equity. This type of equity is concerned with whether data faithfully reflects the world. To think about this, I like to invoke the following metaphor. Data is an image of the world, its mirror reflection. When we think about societal bias or representation inequity in the data, we interrogate this reflection. One interpretation of bias in the data is that the reflection is distorted. We may systematically oversample or undersample particular parts of the world or otherwise distort the readings. It is important to keep in mind that a reflection cannot know whether it's distorted. That is, data alone cannot tell us whether it's a distorted reflection of a perfect world, a perfect reflection of a distorted world, or if these distortions compound. The assumed or externally verified nature of distortions has to be explicitly stated. Another interpretation of bias in the data is that even if we were able to reflect the world perfectly in the data, it would still be a reflection of the world such as it is, and not necessarily of how it could or should be. Once again, it's not up to data or algorithms, but rather up to people, individuals, groups, and society at large to come to consensus about whether the world is how it should be, or if it needs to be improved, and if so, how we should go about improving it. My final point here is that changing the reflection does not necessarily change the world. If the reflection itself is used to make important decisions, for example, whom to hire or what salary to offer to an individual being hired, then compensating for the distortions is worthwhile. But the mirror metaphor only takes us so far. We have to work much harder, usually going far beyond technological solutions, to propagate the changes back into the world, not merely brush up the reflection. Let me now give an example of a concrete approach that focuses on representation equity in set selection and ranking. Consider the task of selecting 4 candidates among 16 job applicants. Our goals are twofold. The first is diversity. We wish to include 2 candidates of each gender and at least 1 of each race. The second is utility, maximizing the sum of scores of the selected candidates, subject to diversity constraints. You can see a list of candidates in the table here, along with their scores. For example, candidate A has score 99 and L has score 83. Observe that male candidates have higher scores than do female candidates of the same race, and that whites have higher scores than blacks and than Asians. The highest scoring set of 4 candidates that satisfy the diversity constraints is highlighted in pink, with a combined score of 373. If we consider the selected set more closely, we observe a problem, and that is that we picked the best, according to score, white and male candidates, A and B, but we did not pick the best Black, Asian, or female candidates. Note that this example was deliberately constructed to highlight the following. If some population groups have systematically lower scores, then it costs less to skip their best scoring members in the name of diversity. This runs contrary to the nature of the diversity objective, which is to equalize access to opportunity. This also presents unfairness under a particular belief system. Suppose that scores represent effort, that is, how hard someone had to study to do well on a test. We may take a relative view of effort and assert that scores are more informative within a group than across groups. Further, we may assert that it is important to reward effort. Taken together, these beliefs correspond to a luck egalitarian conception of equality of opportunity, denoted here with a rainbow unicorn. But there is something we can do. Consider the set of 4 candidates highlighted in blue. This set still meets the diversity constraints, and its score is lower by 1 than the score of the pink set. This utility loss is inevitable, but it is small. Importantly, this set is much better at rewarding efforts across groups. It selects the highest scoring female candidate and the highest scoring Black candidate. Having stated our beliefs and observed the trade-off between diversity, utility, and fairness, we are now ready to design an intervention. For example, we may compute unfairness for a group, like the female candidates, as the ratio of the score of the lowest scoring selected candidate, that is K with score 83, and the score of the highest scoring skipped candidate, and that is D with score 95 in my example. We can then reformulate the selection process to balance unfairness across groups. We did this and quite a bit more in the paper, designing several fairness metrics of this sort for both set selection that I just described and for ranking. We also devised an integer linear program to encode all these constraints. And we ran experiments showing that the utility cost of balancing fairness is low in most cases. Next, let's switch gears and discuss access equity. Access equity is concerned with having access to information, features, data, and models needed to evaluate and mitigate inequity. The point of view I will take here is primarily of mitigating technical bias, making sure that we're able to catch and correct for the imperfections and distortions in the data as it travels through complex data science pipelines. Much exciting work remains in supporting access equity, both in terms of practical implementations and in forming a conceptual understanding of the interactions between pre-existing and technical bias and their impacts on equity. The fair machine learning community considers this work out of scope. Their focus is on predictive analytics that take as input a nice, clean rectangular dataset, crunch it, and produce a result. If we then observe that the result is such that no women are shown ads for high-paying jobs, and no Black candidates are invited for job interviews, then we have 3 choices. We can tweak the input data, for example, upsample or downsample some groups, tweak the result, such as reassign outcomes, or tweak the algorithmic box, for example, add a regularization term. This is useful, but it's a limited view. I'm showing it here as the exercise of fighting a paper dragon. We need to expand our scope and start asking what specifically happens inside the box, how results are used, and importantly, where the data came from. In other words, we need to start taking a lifecycle view of equity. To illustrate some of these challenges, let's look at a specific problem. Consider Anne, a data scientist in a human resources department at a large retailer. She was tasked with developing a model that predicts the level of compensation to offer to successful job applicants to make sure that they are successfully hired. Anne includes candidates' self-reported demographic data together with their employment histories as input. Following her company's best practices, she splits her data into training, validation, and test. She then implements pre-processing, joins some tables, and then interpolates missing values. After that, she performs model selection and finally, tuning and validation. Next, Anne considers the accuracy of the trained model and observes a disparity. Accuracy is lower for female applicants. This presents yet another kind of fairness issue. Considering the complexity of the data pre-processing pipeline, Anne has a long night of debugging ahead of her. Thankfully, she has a hunch. Anne goes back to data pre-processing and observes that the value of the attribute age is missing far more frequently for female applicants than for male applicants. And so she interrogates data interpolation. She compares age distributions by gender and notices differences starting from the mid-30s. and revisits the data cleaning step and selects a state-of-the-art data imputation method to fill in age in customer demographics. Let us extrapolate from Anne's experience and list some other sources of technical bias that may arise during data cleaning, due specifically to incorrect modeling assumptions. Consider a form that gives job applicants a binary choice of gender and also allows to leave gender unspecified. Suppose that about half of the applicants identify as men and half as women, but that women are more likely to omit gender. Then, if mode imputation, and that is replacing a value with a missing value with the most frequent value for the feature, is used, then all predominantly female unspecified gender values will be set to male. More generally, multi-class classification for missing value imputation typically only uses the most frequent classes as target variables, leading to a distortion for small population groups, because membership in these groups will never be imputed. Next, suppose that some individuals identify as non-binary. Because the system only supports male, female, and unspecified as options, these individuals will likely leave gender unspecified. If mode imputation is used, then their gender will again be set to male in my example. A more sophisticated imputation method will still use values from the active domain of the feature, setting the missing values of gender to either male or female. This example illustrates that technical bias can arise from an incomplete or incorrect choice of data representation. Importantly, it has been documented that data quality issues often disproportionately affect members of historically disadvantaged groups. And so we risk compounding technical bias due to modeling or representation choices with pre-existing bias in this data. In a recent line of work done jointly with the very talented Stefan Grafberger and Sebastian Schelter, we developed ML-Inspect, a lightweight data distribution debugger for data pre-processing pipelines. The ML-Inspect library extracts logical query plans modeled as directed acyclic graphs of pre-processing operations from machine learning pipelines that use popular libraries like Pandas and scikit-learn, and combine relational operations and estimator transformer pipelines. These plans are then automatically instrumented and used to trace the impact of operators on properties like the distribution of sensitive groups in the data. Recall the plight of Anne, our friendly data scientist, who is committed to respecting software engineering and data science best practices, but is challenged by the complexity of the pipeline and by the multitude of objectives, including accuracy and equity. How would Anne know whether the pipeline she has constructed works? The answer is seemingly simple. We must enable Anne to do sound scientific experimentation. Sebastian Schelter and I and several of our students built FairPrep, a system that supports data scientists by enabling sound experimentation. FairPrep is designed to enforce isolation of test data and to allow for customization through user-provided implementations of different components. In the remaining few minutes, I would like to address the final and perhaps most difficult dimension, and that is outcome equity. It is concerned with whether and how we can assess and mitigate inequities that are outside the system's direct control. My thinking about outcome equity centers around interpretability and public disclosure. I like to think about interpretability using the nutritional label metaphor. The data management community has been studying systems and standards for metadata, provenance, and transparency for decades. The needs of data equity systems are once again bringing these favorite topics into the spotlight, but with a twist. To differentiate nutritional labels from more general forms of metadata, my colleagues and I articulate several properties. Labels should be comprehensible, short, simple, and clear. They should not be a complete and therefore overwhelming history of every processing step applied to produce the result. They should be consultative, providing actionable information, not just descriptive metadata. Based on this information, consumers may cancel unused credit cards to improve their credit score, and job applicants may take a qualification exam to improve their chances of being hired in the future. Labels should be comparable, implying a standard, and finally, they should be computed incrementally as data travels through complex data-driven pipelines. Bridging to the social aspects of interpretability, I'm also working with colleagues in social psychology on a framework that forms connections between interpretability and trust and develops actionable explanations for a diversity of stakeholders, recognizing their unique perspectives and needs. An important point is that individuals and groups who distrust algorithms may be less likely to harness their potential benefits. And in this sense, interpretability intimately relates to equity. Recent studies found that individuals who are more familiar with AI fear it less and are more optimistic about its potential societal impacts. Education is an important component of supporting outcome equity. Here I'm highlighting a course that I developed and have been teaching to technical students at NYU since spring 2019, called Responsible Data Science. The course I'm showcasing here has been able to attract an amazingly diverse and engaged group of students. All course materials are publicly available on GitHub. Please use them and let me know what you think. And there's also a recent article in which Armanda Lewis and I discuss the pedagogical methodology behind this course. I will also note that I have been developing a Data Responsibly comic book series together and with the leadership of the amazing Fala Arif Khan, whose illustrations you have been enjoying today in my presentation. The first volume of this comic series has been translated into Spanish and French, and translations of the second volume are forthcoming. Another set of activities is on developing public education materials and methodologies. I'm showing here a course that is currently being piloted at the Queens Public Library in New York City called We Are AI. This course is a collaboration between the Center for Responsible AI at NYU, P2PU, a public education nonprofit, and the Queens Public Library. Materials include a series of videos and another comic book series. Both can be used independently, and everything is in the open source. I'm showcasing the comics here. Please take a look, share, and let me know what you think. And these are the final 2 volumes. It's now time to wrap up, and I would like to leave you with a few parting thoughts. In my talk, I gave a perspective on the responsible design, development, use, and oversight of automated decision systems, or ADS. I grounded this discussion in automated hiring tools, a specific use case that gave us ample opportunity to appreciate the potential benefits and to get a sense of the ethical and legal risks. It is clear to me that we, technologists, have an important role to play. But to make progress, we need to step outside our engineering comfort zone and start reasoning in terms of values and beliefs, in addition to checking results against known ground truths and optimizing for efficiency objectives. This seems high risk, but one of the upsides is being able to explain to our children what we do and why it matters. An important thread that runs through our discussion today is that we cannot fully automate responsibility. While some of the duties of carrying out the task of, say, legal compliance can in principle be assigned to an algorithm, the accountability for the decisions being made by an ADS always rests with the person. This person may be a decision maker or a regulator, a business leader or a software developer, or, importantly, a member of the public. For this reason, I see the role of technologists, such as myself, in helping build systems that expose the knobs of responsibility to people. Of course, the systems we're helping build are not simply technical. They are socio-legal technical. In some sense, technology is the easy part. This means that to expose the knobs of responsibility to people, we must work together to create meaningful regulatory mechanisms, a topic on which I touched briefly today. I also see as part of our responsibility as technologists and educators to help create a new generation of AI practitioners and an informed public. Thank you very much for your attention.
Thank you, Julia, for this for the great talk. If there are any questions from the audience, we should take them now. I'm not seeing any yet, but people might be slow. So let me kick off with one question here. You mentioned your talk about the fact that the technology piece is relatively easy, and it's everything that around it makes it even harder. Can you talk a little bit about that interface between the technologists and the other factors that need to be here? I find that to be an incredibly complex topic. What is your experience there?
Thank you for that excellent question, Alon, and thank you for having me in this session. So, of course, this is a bit of a provocation, right? That technology is the easy part. It is difficult, but human relationships, changing human culture, changing the way that we communicate is even more difficult. And I understood that when I had the privilege of being a member of the Automated Decision Systems Task Force in New York City, where a bunch of us came together, some from academia, some from the city government, some of us from technology, and others from the policymaking space, to try and figure out how to oversee the use of automated decision systems in the government. And I came into that exercise thinking that I will learn a lot. And I did, in fact, learn a lot, but I learned completely different things than what I thought I'd learn. I thought I would learn more about how the city uses technology. And what I did learn instead is that unless we are able to create an environment in which we can have a productive conversation, a kind of a safe space where people are not afraid of telling something to academics and then ending up on the front page of the New York Times in a negative light, we're not going to get very far in this conversation. So I do really think that the most difficult part in this conversation now is making sure that we have an environment in which we can trust each other to move forward productively, and also an environment in which we are on the same page about how things work. Meaning that we technologists need to help explain to non-technical people what AI can and cannot do, for example. And folks in government and folks using technology and folks being impacted by it need to have an open conversation with us to explain to us how life works, how government works, for example, so that we can be productive in this. So this is sort of some beginning thoughts along these lines. I'm happy to elaborate.
Actually, I'm going to follow up with that. So, I mean, government operates, and we need to adhere to what government imposes, right? But there are places where the decisions that some of the powers of AI in the world make are maybe in tension with what the governments are trying to impose. And you have the governments, you have technology, and then you have human rights, right? You have, those of us who believe in democracy or whatever, and those can be in tension. So where do, and obviously this is a great conversation for a glass of wine, but where is it that technology needs to say to government, no, we're doing what we think is right?
I don't think that technology needs to tell the government that they are doing what they think is right. I think that governments are not monolithic entities either. I think that the technology sector is not monolithic. There are many stakeholders and many disagreements within government, within technology, within the public sector more generally, and there are also lots of disagreements among members of the public and different constituencies, right? So I don't think the conversation should be we're putting our foot down and saying this is how things are going to be. Certainly not for the private sector. This is not the place. I think that we all need to strive to have a conversation about how to move this work of democracy forward. I do think that we as technologists broadly need to take this magical thinking out of AI so that people don't think that machines know what we mean, right? Because they don't know what we mean. And we understand that, but there's an incentive on the part of the big companies, for example, and generally on the part of the technology sector to keep that magic in place, because that's a way for us to sell products, right, more effectively. So I think that we need to really start and dismantle that narrative. But again, I am an academic, I'm not in industry, so I have the luxury to say that industry should never put its foot down against laws and against regulation.
No, so just to correct the question, I didn't mean against law and regulations, but in government, there are always many sides, right?
Right.
The algorithm needs to do something. And at some point, the algorithm will make one of the sides unhappy. And at that point, you're going to make, the technology will make a difference. But let's move on to a different point because we only have 2 minutes left. The part about explainability, which is something that a lot of companies are working on today. What do you think is from a technical point of view, what do you think is the main thing that we can do in order to educate the public?
Yeah, and I'm glad that we're going to end on that question. So I really don't believe that there is such a thing as the ground truth in any of these conversations. It's very rare that we have the luxury of a ground truth. So being able to explain to various stakeholders being affected by decisions or having a stake in the decisions what the trade-offs are is what it's going to come down to. So I think when we work on explainability methods, we need to be very honest about to whom we are explaining whatever it is that we're explaining, why we're doing that, and just what do we expect the recipient of the explanation to do with that information, right? So explanations do need to be actionable, but then that also means that the person to whom we are explaining the decisions needs to understand the meaning of the proverbial calorie, right? If you take the nutritional label metaphor that I like to use. So this is really an example where education, including public education, is paramount.
And education, does it need to start? So you can try to educate the general public, or you can try to educate the people who are writing articles that are shaping the opinion of the general public.
Yeah, all of the above, right? I mean, we need all the help that we can get here, but I do think that we also need to be explaining to members of the public, not only to people who are representing them, what is going on, because some of these decisions are impacting people individually, and they need to make decisions individually. Do I apply for a particular job, given what I know about the kind of hiring practices or the practices at the company that are done with the help of data and algorithms or not, right? So this is an individual decision to be made.
That's true. Unfortunately, we are out of time. So thank you again, Julia, for the stimulating talk and discussion. I'm sure this is going to be a topic that will stay for a long, long time in our community.
Thank you very much, Alon, for having me.
Bye, Julia.
Bye.